Okay, so to eliminate the parameter and turn it into a Cartesian form, that means we need x and y in the same equation. We're getting rid of the variable t here. So to do that, let's see if we can get t by itself, and then we can make a substitution. So like over here, I'm going to work with this instead of this because, I don't know, it works out either way. But this one seems a little easier because then we don't have 3t in the top, we just have t. It still wouldn't be too bad to work with the x of t function. So divide 3 from both sides, we get y over 3 equals e to the t power. And then to get that t power down so that we can hopefully make a substitution later, let's use natural log, because natural log of an exponent base e, that's an inverse function, so that's going to leave us with just t. Natural log of e cancels out, sort of. Okay, so now we have something to substitute for t. Let's plug this back in. There is a consideration we'll need to make. Here, t can be anything. You can plug in negative infinity, positive infinity. Down here, though, yeah, no, t can be negative infinity, positive infinity. Okay, no, we're okay. So let's take t, we'll plug in natural log of y divided by 3. So x equals e times 3, e to the power of 3 times natural log of y over 3. So if we multiply that 3 to everything inside, oh, actually we can't do that, so it's a 3 on the outside of a logarithm. Let's use the exponent property of logarithms. It's going to cube everything on the inside, right? If you have a natural log b, that's the same thing as natural log b to the a power. So that's the property I just used here. I used 3 and made it come as an exponent on top of everything in there. And now we have e to the natural log power again, so those cancel out. So we're left with y to the third over 27, because that's y to the third and then 3 to the third. X equals y to the third over 27. I don't see that in the list, so with similar to other problems we've done here in Newton, let's rearrange. I'm going to multiply 27 to both sides. And then we have to cube root both sides to get y by itself. So y is going to be, the cube root of 27 is 3, and that's x to the 1/3 power. Does that match anything? No, that one doesn't match anything either. Oh, shoot, we did have an answer. So right here, that matches up with this over here, right? If you divide by 27, that's the same thing as multiplying by 1 over 27. For this one, we have x and y being defined in terms of t involving a logarithm. If we use our properties of logarithms to rewrite it, it's going to be 10 to the x equals 3t. So based on what we see over here, all these involve getting x by itself. We could try to get y by itself, and that's not going to help us answer this question. So let's focus on the y variable over here. To get t by itself, subtract 3 from both sides, and then take a square root. But every time we take a square root, we want to consider, every time we use a square root to cancel out a square, we want to consider the positive and negative answers. But since we're going to substitute this for t, and it involves a logarithm, then we only want to consider the positive option here. We'll drop the negative. So we got log, this is 3 times the square root of y minus 3. Okay, and again, we're not putting the negative sign because everything that comes out of this is positive because it's a square root, and then positive times a negative would be a negative, and you can't evaluate the logarithm of a negative number because a logarithm asks you, what power do you need to raise a base to be to make it equal the value in your logarithm. All right, so we drop that negative sign. This is our Cartesian form, and that matches, looks like this top one up here.